Here we have square root equation and we have to solve for x in this square root equation. That is, we have to find the value of x. Okay, when I look at the given square root equation over here, I find square root for the complete stuff over here on the left side, and also I find square root for the complete stuff over here. So to get rid of the square root over here and here, what I need to do is I have to square both sides of the equation. Okay, let me do it. So square root of x positive square root of x the whole square equals to square root of x times square root of x the whole square. I square both sides. So this square root and square root cancel. This square root and square will cancel out. So on the left side, I'm getting x positive square root of x. On the right side, I'm getting x times square root of x. Okay, now in this term, we have square root of x, and on the right side, this term contains square root of x. So if I get these two terms together on one side of the equation, I'll be able to simplify. Okay, so let me subtract square root of x from both sides. When I do so, this positive square root of x, negative square root of x will cancel out. I'm getting x equals to x times square root of x, negative square root of x. Okay, then x equals to, so I find the greatest common divisor square root of x for these two terms. So I can factor the square root of x out. If I factor square root of x out, then I have x left in the first term, negative 1 left in the second term. Even if I distribute the square root of x to this x, I'm getting x times square root of x. And when I distribute the square root of x to negative 1, I'm getting negative square root of x. So the factoring, what I've done is correct. Okay, let me continue the stuff over here. There is x equals to square root of x times x negative 1. Okay, now I divide both sides of the equation by square root of x. So then square root of x will cancel out. I am getting x over square root of x equals to x negative 1. Okay, still the troubling part is a square root over here. So until we have square root here, we cannot solve this equation easily. So to get rid of the square root, I'm just taking square on both sides. So when I take square on both sides over here, on the left side we have a square for a fraction. Whenever we have square or a common exponent for a fraction, the exponent can be taken separately for numerator and separately for denominator. Then I'm getting x square over square root of x the whole square. And here we have square of a binomial on the right side. I can use the algebraic identity, that is a minus b whole square equals to a square negative 2ab positive b square to expand the square of the binomial over here. So when we have a negative b the whole square, first we take a square. Since we have negative sign over here, we take negative 2ab positive b square. Okay, now comparing this a negative b the whole square, x negative on the whole square, I have x at the place of a and 1 at the place of b. So for a square into 2ab positive b square, what I have to do is I have to write x square negative 2 times. So for this a, I have to plug in x. And for b, I have to plug in 1. Because instead of a, we have x, instead of b, we have 1. Positive b square means I have to write 1 square. So this x square over here can be written as x times x over, and this square root and square will cancel. I just get x in denominator, and 1x in numerator, 1x in denominator will cancel out. I'm getting x square negative 2x positive 1 on the right side. Okay, now we get x equals to x square negative 2x positive 1. So now it's a quadratic equation in the variable x. Okay, so to solve for x or to solve for a variable in a quadratic equation, I have to get it in standard form. What is standard form? That is ax square positive bx positive c equals to 0. That is, we must have everything on the left side. On the right side, it has to be 0. So here, we can get rid of this x over here, so that we will be getting 0 over here. Let me subtract x from both sides. When I do so, this positive x negative x will cancel out. I'm getting 0 on the left side. I'm getting x square. And when I combine negative 2x and negative x, I'm getting negative 3x positive 1. Okay, now let me write the equation over here. That is x square negative 3x positive 1 equals to 0. Now this quadratic equation is in standard form. So when I compare this equation with ax square positive bx positive c equals to 0, I am getting a equals to 1, b is equal to negative 3, and c is equal to positive 1. Okay, so immediately I compare the standard form of the quadratic equation to ax square positive bx positive c. So because I want to get the values of a, b, and c. The reason is this quadratic equation cannot be solved by factoring. So I have to use quadratic formula to solve this quadratic equation. That's why I just compared the quadratic equation over here with ax square positive bx positive c equals to 0 to get the values of a, b, and c. I got a is equal to 1, b is equal to negative 3, and c is equal to 1. And the quadratic formula is x equals to negative b positive or negative square root of b square negative 4ac over 2a. Okay, now x equals to negative, the value of b is negative 3, and positive or negative square root of b square means we have to take square for the b value, that is negative 3 the whole square. Negative 4 times the value of a is 1, c is 1 over 2 times the value of a is 1. Then x equals to negative times negative will become positive. So 3 positive or negative square root of When I evaluate this negative 3 the whole square, it will just become 9. Negative 4 times 1 is 4. Again, 4 times 1 is 4 over 2. So I'm getting x equals to 3 positive or negative square root of 5 over 2. Okay, now we can split up this solution. That is 3 positive square root of 5 over 2 is the one value of x. 3 negative square root of 4 over 2 is the second value of x. So when I solve the given quadratic equation, I'm getting, not quadratic equation, the square root equation, I'm getting two values for x. So one value is 3 positive square root of 5 over 2. The other value is 3 negative square root of 5 over 2.